name is Joey Bourgeois, and this is Automatic.
Automatic is a watchOS times iOS application that utilizes the Apple Watch's powerful accelerometer, magnetometer, and gyroscope to recognize the wrist gesture of a basketball shot. Accelerometers and gyroscopes on the Apple Watch have the ability to derive data at a rate of 100 Hz or 100 times per second. Such motion data can be collected and through Apple's Create machine learning software can train a motion activity classifier to depict distinctions between basketball shots and all other universal hand motions. Automatic can track the shot to the user without the user even having to touch the watch once after starting the session. That's right, everything happens completely in the background. Combining this AI recognition and metric data from the motion sensors, Automatic can also return basketball-related statistics per every shot, providing insightful feedback to the user, which improves their jump shot. Okay, so now let's take a look into the code. I'm not going to go into everything in deep detail because it is a 400-line algorithm / program that I wrote, and it has a lot of depth and a lot of stuff to go over, so I'm going to go over the most important stuff. So as you can see up here, we have our data lists. That's going to be explained later in my program, but these data lists are basically holding all the motion data from the accelerometer, the gyroscope, and the device orientation of the Apple Watch. And so are these AI data lists. The only difference is that these AI data lists are being used to make predictions by the AI. Right here I have my model. I called it best model because it was my best one. Right here is my extended runtime session functions. So this is actually the syntax and Xcode that allows me to run code while the watch is not on, or if the app is not actually in an active state, we can run code from this function. Right here I got a lot of my variables, just setting up a couple stuff, making sure everything's working, setting up all my classes, my objects. So right here is my first big function. It's an IB action function, so that means whenever something happens to this button. So in this case, whenever the button is clicked, we are going to start recording. And as you can see here, we do session.start. This is starting the background mode of our app. And the background mode is going to run on a constant loop. Right here, we have start recording. So this is the biggest chunk of our program. And this is really what makes or breaks Automatic. This is the function right here that does everything. It does it all. So we have a timer and we put a timer on an infinite loop. So that means that all this code right here that I'm about to highlight is running on an infinite loop over and over and over again until I invalidate it. From here to here. This is the line of code that stops it. So we have a lot to go over. So first, right off the bat, we're just grabbing all of our variables, right? We're grabbing the acceleration XYZ, the angular velocity XYZ. We're grabbing our angle in degrees. We're grabbing our magnitudes. We're grabbing all of our orientations. We want to get all this data for each single hertz ready, right? Because this function is getting called every single hertz, which means it's getting called 100 times a second. So right here, we are basically filling up all the data lists, right? The data lists have a length of 100, and we fill all of them up until the length is 100. And then once the length reaches 100, we remove the first index, and then we add one to the end of the index. What this does is, this allows us to make predictions sort of on a continuous sliding scale. So for example, if we have 105 data points, we can start with the first 100, make a prediction, then slide down one to the right, which would go from 1 to 101, we'd make a prediction with that. And then we'd go from 2 to 102, we'd make a prediction with that, 3 to 103, and so forth. That is what we're doing here, and this is the best way to ensure that the basketball shot is encapsulated from start to end, no matter what. If we continuously make predictions every hertz, we are going to eventually run into a shot motion if somebody were to shoot the ball. Right here is our predict function, and I really think that is the last function we're going to go over. This pause function basically just makes it to where if a shot is predicted, the function pauses. But let's go over this predict function right here. So right here in our predict function, this is going to be right here in this highlighted portion is going to be our model prediction. This is going to give us either a prediction with confidence that it's a shot or that it's not a shot. If there's a 95% confidence based on the data that it is a shot, we're going to return shot. And when we come back up here, as you can see, if predict equals shot, which would happen if there's a 95% confidence, we're going to derive the angle and print it to the screen and pause and then remove. We got to do a whole lot of reset stuff, remove our lists, all type of that stuff. I do want to go over real quick this derive release angle. So the magnitude is basically the total vector of the X, Y, and Z acceleration. And when we add that together, it actually gives us a good picture as to whether or not the object is in motion. So if a magnitude is below 1.2, that means that the watch is probably not moving that much. And through this, we can iterate through the list of magnitudes and figure out actually throughout the shot when a brief pause came to commencement. And once we figure out where that brief pause is, we can actually go into the degrees list and grab that angle, and that would be our release angle. So yeah, so that's all I have today. Obviously, this is a never-ending app, and so far we got the release angle, we got the AI recognition, and hope you guys enjoy.